Okay, so we continue with our checkpoint 11 to 13. I think from questions 1 to 21, we've dealt mostly with IPv4 addresses. We found ways to find the network ID, find the number of host addresses in a given subnet, find the number of subnets that we can create, even to the extent of subnetting itself. Um, the couple of following questions will mostly be focusing on IPv6, starting with number 22. I think we'll be very quick with these answers. 22, IPv6 address valid link local. So when you talk of link local addresses, it's valid if it has FE80. If an address starts with FE80, 64, that is a link local address. I think there are a couple of addresses that you need to know. For example, this one, there's also this one. If an address starts with, okay, let's just talk of this network. That is a multicast address, FF00. All right. Uh, then we have this one, that is a non-address as well. Lubeck address. So for this one, our answer is definitely C, FE80. Every time you hear link local, it's definitely FE80. 23, shortening the address. How do we shorten that one? We have two ways of shortening the address: removing zeros, omitting zeros, if I can say, omitting the leading zeros. Then we don't, there is another one of using the double colon as well, replacing a string of zeros with the double colon. So for this one, C, 00, double colon, 1, 2, yeah, 1, 2. I think C works. C is correct. So we shortened this one. We remove these zeros. We remove the leading zeros. Let me be correct. So we remove the leading zeros. We remove this one. And we replace these ones with a double colon. That's how we shorten that one. We also remove these leading zeros. These ones also removed. And I think that is our answer right there. C, 3FE 1044. Yeah, I think C makes sense. Number 24, a network administrator is an IPv6 address /48 for subnetting. Assuming administrator does not subnet into the interface ID portion of the address, how many subnets can the administrator create from the /48 prefix? How many subnets can we create? How many bits? To find the number of subnets that we can create, we find the number of bits that we have for the subnets. So for a /48 network, it obviously means we have 16 bits for subnetting. So the number of subnets that we can create is 2 to the power of 16, which is, I think, this number right here, 65,000 networks that you can create. 25, given the IP address, that one, what will be the last subnet that is created if the prefix is changed to /52? So let me see, the last network that is created, we have a /48, which goes to a /52, meaning we have how many bits for the subnet? We have 4 bits for the subnet. Is this 4? Yes. So we have 4 bits for the subnet. And what will be the last subnet? The last subnet will be the one which has 1, 1, 1, 1, I think. Does that make sense? 4 bits, one which is F, 0. Not this one, not this one, 0. Okay, this one needs a little bit of thinking. All right, let me bring up this. This one needs a little bit of explaining, I think. 2001, 2001 DB8, 48/48. So we moved it to slide 52. We want to find the last subnet. Right. So with a slash 48 moving to a slash 52, it means we have 4 bits that we have borrowed from the host. 4 bits translate to one hexadecimal value. So it's basically one hexadecimal value which is being used for the subnets. So the number of subnets that we are going to have is 2 to the power of 4, which is 16 subnets. So the first subnet will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, then F. These are the 16 subnets that you create with. Where are we getting that? We're getting from the 4 bits is from the one hexadecimal, which we get from representing a 14 bits. So these are the subnets that you create, and the last one in again F. That said, here we have slash 58 going to slash 52. All right. 2001 DB8. How many bits do we have here? We have 16 bits here, 16 bits here, 32. Up until we get to 52 bits, how many are left? 20. So I can put 16 again here. Now, what is on those 16 bits? Since we have a double colon here, that double colon represents a string of zeros. That's why we have that string of zeros representing another 16 bits. Now we have 16, 16, 16. That's 48. 48, how many left? 4. 4 bits left. So the 4 bits left is the F, which is coming in from the subnet. That's how we get our subnet right there. I think answer will be, let me see, C. Answer will be D, C or D. Is there anyone in the chat? D, C or D? Why D? If I have 0, 0, 0 here, this portion is now the host. Okay, it makes sense. So the answer is D. So this one was shortened to 0. The answer is D. Okay. A little bit of thinking and reasoning required for this one. But I think very important understanding how do you subnet in IPv6. It's almost the same logic with IPv4, a bit different here because you have to maneuver through the binary, then you go to the hexadecimal. That's where it gets a bit tricky, but I think the same way we dealt with IPv4 will be the same way we deal with IPv6. So for this one, our answer is D. I consider the following range of addresses. The prefix length for the range of addresses is prefix length. We just count the number of bits that are being used for the network. Let me see. So we have 16 here, 16 here, 16 here, 16 here. So already 16 times 4. That's 64. Then we have 000, 1, 2, 3, 4, 000, 1, 2, 3, 4, 000, 1, 2, 3, 4. This is slash 64. There is this one again. No, this is not a slash 64. This question's becoming a bit tricky. What are they asking here? The prefix length. The prefix length shows us the network ID, the network portion. How do we separate the network portion from the host here? Prefix length should be here. I think it's more than 64. 1, 2, 3, 4, 5. What is 16 by 5? Slash 80. It's not making sense to me. But it looks like this is a slash 80. Yeah, we don't have a colon. Are you following? Yes, following. I need more senses, more brains here. I'm trying to figure out the question if what exactly are they asking? Do you understand what they're asking? Do you get what exactly they're asking? Because we might answer a question which has been asked the incorrect way. The prefix here, we have 1, 2, 3, 4, 5, but we don't have the double colon. That's where my problem is with this one. Okay, question mark for this one. Let me see. What was their answer? 27. Explain. Link local IPv6 site with FE8 slash 10, which is any address from FE8. Link local addresses are exclusive. Are those link local addresses? Oh, no, they're not link local, these ones. Right, I think we'll leave this one. I'm not getting the question. I think there is some missing information on this question. We'll just leave this one. 26, we skip. But 27, I was looking at the wrong number. Number 26. Explanation. All the address have the part 2000 in common. That's the network. Okay. Each number or a letter in the address represent 4 bits. So the prefix length is slash 60. Let me see. 26. Okay, so the logic is the network portion is the same. So it's the same up until to this point. Okay. That makes sense. All right, for this one, I was completely lost. All right, for this one, we're trying to find the prefix length. To find the prefix length, we look at the network portion of all these addresses. And we know that the network portion is identical. That prefix is identical for all addresses that belong to the same network. So looking at these addresses, the identical part, ikugumira pana A apo, the identical part, meaning this part here is representing the network portion of the address. Now, to find the prefix length, we have 16 bits, 16 bits, 16 bits, that's 48. Then we have 4 here, 4 here, 4 here. That's 12. 48 plus 12, I think That's where the 6 is coming from. Makes a lot of sense. Makes a lot of sense. I couldn't understand the question in my head. Okay, continuing. Number 27, type of address is FE80 link local. We've gone through that. Multicast. Why so tricky? It's an exam. That's why it's so tricky. This is an exam. That is now a typical question in the exam where you don't even know where to start. I couldn't figure out where to start exactly. Blacked out. It happens. Multicast, you need to know these addresses now. Multicast, if you see an address with FF00, I think it should be /10. I know of FF0, I think you should know this one, 02. That's a multicast address, or not multicast address. FE80, that's a link local address. That's a loopback address. A global unicast. These are typical global unicast addresses that are available. So you need to be able to identify my addresses are. Right. Refer to the exhibit. Company is developing an addressing scheme for its network. Company design documents indicate that the subnet portion of the address is used for a new hierarchical or network design with the site subsection to represent multiple geographical sites of the company. The subsite section to represent the multiple campuses, the subnet section to indicate the network segment separated by routers. With such a scheme, what is the maximum number of subnets achieved per subsite? A maximum number of subnets per subsite. Okay, easy. If the question comes with, for example, number of subnets, number of hosts, you know what you're going to be using is this formula or this one, where n is the number of bits either for the network portion or for the host portion. So for this one, we're looking for subnets, subsite. We can see the subsite is 2 hexadecimal values. 2 hexadecimal values means 8 bits. This is hexadecimal. Those two values, they represent 8 bits. So 2 to the power of 8, is that not 2 to the power of 8? Let me see my answers. 2 to the power of 8, it should be 256. I hope. Actually, it is. So that's the number of subsites that we can have. IPv6 addresses, they're a bit tricky because their representation is in hexadecimal. You need understanding this value E2 is representing 4 bits. So this 2 is a representation in hexadecimal, which, let me do this. So if this is X, then the binary representation will be 00110. So this 2 here is 4 bits, is this number. Then we have a 0, 1, 2, 3, 4, 1, 2, 3, 4. Then we have a 1, 1, 2, like this. So these 4 digits, they're represented by these 16 bits. I think this will assist you in many ways, understanding that. Right, 29, what is used in the EUI64 process to create an IPv6 interface ID? What is used is a MAC address. The MAC address, I think this one. Yes, voila, this one is easy. So there's some gymnastics which are done to that MAC address. There is a value which is inserted in the middle of the MAC address. Then there is also the 7th bit of the first octet, which is flipped. That's how we get the EUI64. Probably for the sake of revision, where where does EUI64 come in? When we are configuring our addresses via Slack or via Slack with DHCP or via DHCP stateful. Right, when you are configuring using number one, there is an exchange of messages which is done, router solicitation, router advertisements. Router advertisements, they come with the network prefix, but there is no host portion there. How does the device get the host portion? It either uses this process or it randomly generates the host portion. So that's where this EUI64 comes in. What is the prefix of the host address? The prefix. Okay, we have host address is /64. So the prefix, first 16 bits, obviously. 16, 32, you're going to have an A up. That's the prefix. The prefix represents the network portion. The network portion, how do we find it? We use the prefix length. First 64 bits represents the network here. So we have 16, 16, 16 up to A, meaning our answer will be B. Not B, say. Are you saying it's not B? Okay, got it. It's B. Okay. It's B. All right, 31. An IPv6 enabled device sends a data packet to the destination FF02, double colon 1. What is the target? This is a multicast or not. E, and then or not multicast address E or. So it's the target of this packet is every device on the local link or IPv6 enabled devices on the local link. Answer B. With revision, you need to be able to look at this address and know exactly what it means. You should be able to look at this address and you know exactly what it means. Those are familiar addresses. Let's move. 32, match the address with the address type. Right, so, okay, they already matched here. This is the O node. This is the solicited node. Global unicast. Okay, these ones were already matched. I think the answers are already there for this one. 33, which prefix is reserved for communication between devices on the same link? That's the link local address. The link local address, the LLA, is reserved for addresses on the same link. It's like addresses on the same network, basically. Then we have the GUA, which is used to communicate globally. When you want to communicate with the remote network, what you use is the GUA. Local, you use the link local address, and the prefix is this one. Which type of address refers to any unicast address that is assigned to multiple hosts? That's in unicast D, yes. Unicast. Number 35, two types of addresses. So for this one, we have link local and what are two types of IPv6 unicast? Link local is unicast. Anycast, is it unicast? Uh, okay, let's remove. Maybe anycast, it might be unicast. Broadcast is definitely not unicast. This is not unicast. This is not unicast. So I think I'll take these two answers, B and C. Loopback. A loopback address is sending a packet to, is when a device sends a packet to itself. That's a unicast address, sending to one device. Keyword here is unicast. Okay. Number 6, which service provides dynamic global? addressing to end devices without using a server. Without using a server, so it's like that is the one that does not use a server. This one, it tracks, that is stateful DHCP. This one, that's static IPv6. Here we're talking of dynamic, so this one is out. Stateless DHCP, stateless. Stateless actually means the opposite of this, keeping record. So if you are keeping record, if a server keeps record of addresses or of any information, it is called stateful. If it does not keep records, if it does not manage, if it does not monitor, it is called stateless. So I think these are words you will see, I think, very often going forward. Stateful and stateless. In their meaning, is linked to managing, tracking, monitoring of information. Right, 37 protocol, which protocol supports Slack? ICMP v6, UDP, this is a layer 4 protocol, transport layer, DHCP version 6 with Slack as far as I know, because Slack is actually stateless. Stateless address auto configuration. So it's stateless. The moment we have DHCP, then we have stateful. So it's not the protocol, this one. ARPv6. Do we have ARPv6? Question. And then the response to this one. Does the protocol ARPv6 exist? Yes or no? No. Thank you. There's nothing like this. What is the equivalent of ARP in IPv6? Another question. ARP is a protocol used in IP mapping IPv4 addresses. What do we use in IPv6 addresses? What's the protocol called? That protocol is the NDP, Neighbor Discovery Protocol. Voila. Neighbor Discovery Protocol, and it makes use of ICMP v6, NS, and NA. All right. Number 38, 3 methods allow IPv6, IPv4 to coexist. Okay, they're already meshed. So we have 3 ways. These ones, dual-stack, where both version 4 and version 6 packets coexist. Tunneling, where the IPv6 packet is transported, is encapsulated within the IPv4 packet. Translation, we translate IPv4, IPv6 packets, or vice versa. Simple. Or a technician uses the ping of 127.0.0.1. What do we call this address? That address is what we call the loopback address. The loopback address is used to test the functionality of the hardware, of the software, of a device. So a device sends a packet to itself, therefore testing the functionality of that device. So what is the technician testing? The TCP stack on a network host. This can be an answer. Connectivity, no. Connectivity, no. Connectivity, no. Connectivity, no. So that's our answer there. Testing the IP stack on a network host. Basically, it's testing if the device is functional. if we want to be simple. That's how we test if a device is functional. If that packet doesn't get a reply to that ping request, if it doesn't get a response, then your device is not functional. Right. Number 40, refer to the exhibit. An administrator is trying to troubleshoot connectivity between PC1 and 2. These questions, I need to know around the pictures. Be very careful with these questions. Do pane basa ipapapo muexam. And this is the most part of the questions you'll be getting. Oh, an administrator is trying to troubleshoot. Okay, it's using traceroute. Traceroute uses which protocol? I need the response based on the displayed output. Where should the administrator begin to troubleshoot? Traceroute uses which protocol? ICMP. So gig. So traceroute basically looks at hops. RS, no, it uses ICMP. Traceroute, the difference between ping, both ping and traceroute, we can use them to test for connectivity, but traceroute uses hops. Uh, what's the easiest way to define a hop? Hops basically on our router, this is the first hop that we have. This is the second hop. I think we only have two hops. So the traceroute shows you this first hop, kuti tasvika this interface, tasvika this interface. Painenge isina kusvika ndo panouya marequest timeout aya panenge isina kukwanisa kupfuura, if I can say, failing to find the right words to explain the hop, more technical. So basically that's how traceroute works. With ping, it only tests for connectivity between these devices directly. So it does not give details, if I can say, of where the problem actually is. It just tells you there is no connectivity. But with the traceroute, you can be able to find, okay, at this router, Dopa traffic, because of the hops that are being showed by result traceroute command. So for this one, our problem will be we are going from PC1 to PC2. Yagumira banani 192.168.1.254. I think it's the network ish. So it's router rinobuda network rakugumira up. So pane problem, where should the administrator begin to troubleshoot? Troubleshooting yedu inofanira kutangira parouter iri, because traffic haisi kusvika painterface rinori. Our answer is D. Router 1. Explain router 1. Explain router 1. Because what I'm seeing is our packets are getting to this interface. And this interface is definitely this first hop here. That's where the first trace route is recorded. Yes. If it's recorded, it means packet redo rasvika baba. Rasvika. So it means this interface is functional. So troubleshooting here inotangira pa the next interface, because hatisi kukwanisa kusvika pa the next hop. Ndosaka riri kunzi request timeout. If you do get to the next hop, raifanira kuti pa-address yepanapa, then tozout everything sorted. So problem iri parouter iri. I hope you get it. And I hope I'm correct. Right, number 41, which protocol is used by traceroute? ICMP. SNMP is a protocol used for network monitoring. But R1 panekanya. Panekanya ke. Hapana nyaya. Let me define hopes. I think let's define my hopes. Let me see. Let me find a proper definition here, hope. What is a hope? Hope in routers. It's not routers. Mm. Hope refers to a package of a data packet from one network segment to another. Each time a packet is forwarded from one router to the next, it is considered a hop. So every time we move from one router to the next, that is what defines a hop. Okay. So my hops aid when we move from one router to the other. The start that the first hop, default gateway, then the next hop will be this one. Let me go through. I think I have less than 1 minute up. It should be stopping any minute. So let me just stop, use the same link, trigger one more session. Chatting where to be. Okay, understood. I want to go through my interfaces are one serial and one Irigo switch. Let me go through the interfaces in the router always.